Let's jump right into lesson 12. In lesson 12, you're going to learn all about analysis of variance, or what we call ANOVA. Analysis of variance is a statistical test that's a little bit different than the tests that you've been doing up until this point. We've been doing t-tests, which look at mean differences between two groups. But ANOVA is going to allow you to look for mean differences among 3 or more groups. So because it's a little bit different, we're not just limited to 2 groups anymore. We have some different types of calculations we do to find differences between 3 or more groups. Let's go ahead and take a look. So in this section, we're going to go over the logic of ANOVA. We're going to talk about controlling for experiment-wise error and what are the hypotheses that we use with ANOVA. So the purpose of ANOVA is so similar to the t-test that we've been doing in the preceding lessons. We're looking for whether there are mean differences between groups. And we're going to determine if those mean differences are statistically significant. So ANOVA is used when there are more than 2 means being compared. And you might be saying, well, why don't we just do a whole bunch of t-tests? You could do that. Let's say you have 3 or more groups. You could do t-test between all the different possible pairs. But when we do a bunch of t-tests, we increase the risk of type 1 error. And every t-test inflates the alpha. We call this experiment-wise alpha level. So it increases the chance that we're making error when we do a bunch of t-tests. But ANOVA allows a researcher to evaluate all the mean differences using a single hypothesis test. We're going to use a single alpha level, and this will minimize the risk of type 1 error. So this is what it would look like if I were doing an ANOVA with 3 different groups. I have 3 different samples, and I know the means of those samples. The first sample has a mean of 2, the second has a mean of 4, and the third has a mean of 6. What I don't know is the mean of the populations that they came from, so I need to do some testing to see. So I'm going to determine whether the sample mean differences provide evidence to conclude that the population mean differences are significant. Remember, when we're testing, we're really generalizing to the population. We're not saying that these samples are different. We're saying that the samples, the population that these samples came from are different. So we could say that there are no differences between populations. Any differences are due to randomness. So this is our null hypothesis, would be to say that all of the groups are the same basically in their means. Or we might have an alternative hypothesis says that there are differences and they are the result of the independent variable. There are systematic differences. So these are going to be the 2 types of hypotheses that we're going to be using. So the null hypothesis for an ANOVA states that there are no mean differences above the populations. In other words, the null hypothesis looks like this. The mean of group 1 is equal to the mean of group 2 is equal to the mean of group 3. Now in this null hypothesis I have ... at the end, and that's just to show that the null hypothesis could go on to however many groups that you have. So if you have 5 groups, you're going to have equal to 4, equal to 5, etc. So that's just what that illustrates. But the null hypothesis says that the mean of all the groups are the same. There's no difference. The alternative hypothesis for ANOVA states that there are mean differences among the populations. The mean of group 1 is not equal to the mean of group 2 is not equal to the mean of group 3. So when the null hypothesis is rejected, the conclusion is that there are significant mean differences. So ANOVA simply establishes that differences exist, but here's the downfall. It doesn't indicate exactly which treatments are different. So we're going to have a single test statistic that will let us know if differences exist between the groups, but that single test statistic doesn't tell us which groups are different. Are all the groups different from each other, or is it just groups 1 and 2 that are different from each other? We can find that out later through some different testing. But ANOVA just tells us if there are differences between the 3 groups, the 3 or more groups. And that test statistic I talked about is something called an F-score. We're going to be learning about this, We've been using the t-statistic to evaluate our null hypothesis, but now we're going to be using an F-score. And an F-score identifies if there's a significant mean difference among the groups between at least two of the samples. So as long as there's a difference between two of the samples, we're going to have a significant F-score. But again, it doesn't identify where there is a difference. That requires more calculations and some more specific comparisons that we're going to talk about later. So here's an example of an ANOVA. Let's say that we want to test the number of problems that are solved correctly, maybe it's on a math test, with 3 different treatment groups. One group is in a room with 50 degrees. One group is in a room that's set at 70 degrees Fahrenheit, and the third group is set at 90 degrees Fahrenheit. So the question is, does treatment impact performance on this test where they're solving problems? So we have an independent factor and a dependent factor. And the independent factor is the grouping variable. It's the variable that we manipulate as a researcher. I'm going to put some people in a 50-degree room, some people in a 70-degree room, some people in a 90-degree room. That's the independent variable. The dependent variable is the number of problems that are solved correctly. So the independent variable, in this case, we call factors. And the independent variable is nominal. Group 1, Group 2, Group 3. So when we're doing ANOVA, we might have groups, 3 different groups, or we might have 3 different levels that we're working with, small, medium, and large, for example. So the independent variable is a nominal variable. The dependent variable is what we measure to see if there's a difference between these groups. And these are scores or values, and these are on a ratio or an interval scale. So let's do a learning check, true or false. ANOVA is a statistical procedure that compares 2 or more treatment conditions for differences in variance. Think about that for just a second. And that's false. It might have sounded true, but even though ANOVA says analysis of variance, it uses variance, but the purpose is to evaluate the difference in the means of the groups. So even though it says analysis of variance, we're really looking for a difference in the means of the groups. So this gives us a quick introduction to what ANOVA is. And in the next video, I'm going to talk with you about the logic of ANOVA.